In this experiment, we are going to do a non-inverting operational amplifier. The amplifier that we are using, the op-amp that we are using, is the same as the one that we used in the previous experiment. And again, you can find the datasheet with this link, which is this. And the configuration that you need to build, it has been shown in figure 1. The values of these resistors has been shown here. So I'm going to construct this circuit, build this circuit, and continue to the next steps. So as you can see in figure 1, there is 1K from the positive input of the amplifier to some node called Vin, and there is 100 ohm from the positive input to the ground. There is 1K from the negative node to the ground, and there is 10K between the negative input and the output. So again, the configuration that I have used is, so these are the same as before. These are the two grounds of the power supply and the ground of the oscilloscope. This is the input of the function generator. We are not going to use it for now. I'm going to put it somewhere else. This is the output of the oscilloscope to measure either the voltmeter value or the oscilloscope. This is the negative of the power supply, which is negative 5 volt, and this is the positive of the power supply, which is positive 5 volt. Now I need to put R4 between the output and negative pin, which is the second pin. So I'm going to put this somewhere here. Okay. Then from negative to ground, we have R3, which is 1K. So from negative, from negative, which is the second one, to the ground. Okay, let me make sure that this one is inside too. So the 10K is between, so the 10K is between 1 and 2. The 1K is between 2 and ground. Because I need more ground connections, I'm going to make another node as ground. So I'm going to connect this node to somewhere here to have more grounds. Or here to have more grounds. Then from positive, I'm looking into the figure in the manual, so you need to do the same. From the positive of the op-amp, you have R2 to the ground. So R2 is 100 according to the manual. R2 is 100. So from the third pin, you have 100 going to the ground. Okay, and then you have a 1K from that positive node to somewhere, so that you can give the input. So I'm going to put this here, positive, and somewhere that I can inject the input. So again,
this one is between the node 3 and the input. Input is going to be here. This one is between node 2, node 3 and the ground, which is connected to this is ground here. And we have a 1K, which is R3, between ground and the negative of the op-amp, and we have a 10K between output and the negative input. Now again, like the inverting amplifier, you will have the voltages that you need on board, on the breadboard. This is positive 5. This here, the white one is negative 5, and this node which has been connected with this yellow line wire here is ground. Okay, each time you need to give your input, which is here. You need to connect this each time to one of these. Once to the positive 5, once to the negative 5, and once to the ground. I'm going to do this for the positive 5, and you're going to do the next to yourself. So I'm going to connect this to positive 5. Okay, and I'm going to measure VB, VC, and V out. So for V out, we need to connect our wire of the oscilloscope to pin 1, which according to the datasheet is pin 1, and for VB you need to connect it to the positive node of this op-amp, which is pin 3 here, and for the VC you need to connect it to the negative of this op-amp, which is node 2. So I'm going to show them once again. This one here is B, and this one here is C. And the first row, first pin is B out.
Now we move to the waveforms environments. You need to again make sure that the supplies are connected, positive 5, negative 5. I want to remind you once again that make sure that the connections for the supply are correct, otherwise you will damage the op-amp and it will even burn. Then we need the oscilloscope or either multimeter, voltmeter. So I'm going to close the oscilloscope. I'm going to use voltmeter. Then you run the supplies and then you run the voltmeter, and you can see the value of the output in this step. Then I'm going to move the wire of the oscilloscope on the circuit to node B. First I stop everything. I'm going to move the wire to node B, which as I mentioned is the second one, as we can see. Third one, as you can see here, the third pin. So I have moved the orange wire of the oscilloscope to this pin from here to here, and now I'm going to here. I'm going to run this and run this, and you can see that the value has changed. Once again I'm going to stop it, move the wire to node C, which is node C, which is the negative input to the op-amp, which is 2. So on the circuit, I'm changing the wire to node 2. I have connected the orange wire to node 2, and now I'm going to again run the supplies and run the voltmeter. In the next steps, you need to change the input to this input to 0 and -5. Okay, I have done the measurements for +5. As you saw, you need to do the same procedure when you connect this node to 0 and -5, which is on your breadboard available. You have these voltages on your breadboard.
The next part of the question, meaning 3.2, is asking you to shunt R2 with a resistor with equal value and then measure the voltage at different nodes. So you can see here that this resistor has been shunted with another resistor with the same value. It means they are in parallel, and this node is one of the nodes, and this node is another node. The next part is asking to shunt R1 with a resistor with the same value. So you can see that this is R1 and this is another R1 in parallel with the existing R1. The next part of the question is asking you to short circuit R2. It means that you need to put a wire in parallel to R2. So one of them, as you can see, is connected here in this pin, and the next one goes to the other pin. Okay, so it's like you're short circuiting this resistor. The next part of the question is asking you to inject a 5 volt 1 kilohertz. However, you're going to inject a 2 volt 1 kilohertz sine wave to the circuit. The only thing that you need to do is to add this wire here to the 1K, the input 1K resistor, and get rid of the wire that was for injecting the 5 volts from here to the input.
So the next part of the question, as we built the circuit for 3.3, you are going to give a 2 volt peak, not a 5 volt peak, a 2 volt peak, 1 kilohertz to your circuit, and measure the voltage at nodes out B and C. So I have given a sine wave 2 volts 1K, and the supplies are on 5 -5, and the output of the oscilloscope. The next part of the question is asking you to increase the amplitude until the voltage saturation is observed. So what you're going to do is simply increase this to 3 volts, see the outputs, nothing has changed, 4 volts, see the output, you can see the saturation, and you need to explain what is happening. You don't need to do part 3.3C again, because the precision is not available to do this part.